In this video, we continue chapter 3 and we look at nominal discount rates. So we had earlier looked at nominal interest rates. Now we're going to do the same for discount. So I'm going to begin with a review question though, a review example. So I'm going to step off the screen. Please copy these notes down in your notebook and then press play again and we can move on. All right, so I'm going to start with a throwback example about nominal interest and monthly effective interest, all right? So how much will $2,000 be worth in 6 years if the nominal interest rate compounded quarterly is 8%, all right? So I have a present value of 2,000 and I'm trying to push that 2,000 6 years into the future. And my nominal interest rate compounded quarterly, the notation of which would be I superscript 4 in parentheses, I4 is 8%, 0.08, okay? So I've got my present value, I've listed the number of years, and I don't have to say years because our default measurement for time is now years from now on. And there's my nominal interest rate compounded 4 times a year of 8%. Now, I'm never going to use the nominal rate by itself in a computation. I always need an effective rate. So I'm going to take my nominal rate and divide it by 4. And 4, because there's 4 quarters in 1 year. This is a nominal rate compounded quarterly. So I divide by 4, and that gives me 2%, 0.02. So that means that every quarter, every 3 months, every quarter, we get 2% compound interest, right? Okay, well, let's go ahead and use the formula we picked up in an earlier video. The accumulated value after t years is the present value times 1 plus our quarterly effective interest rate raised to the 4 times t power, all right? I'm going to throw in t equals 6 in both spots. I'm going to throw in the present value of $2,000, and our quarterly effective interest rate was 2%, all right? And that would then crank out the 3216.87. Now, this is the same as saying, well, look, I have in 6 years, that's really 24 quarters I wish to move into the future. So there's the 24th power saying, let's move 1 quarter at a time, 24 times. And each quarter, you're getting 2% interest, which is what this time value diagram of money would indicate. 0 quarters to 24 quarters and a period effective, quarterly effective interest rate of 2%, all right? Okay, well, now let's do the exact same thing, but with compound discount. So we might wish to utilize compound discount more or less frequently than once per year, all right? So going from annual effective compound discount to maybe monthly effective compound discount. Okay. All right, well, terminology, D will be our annual effective discount rate. M will be the number of times per year that we either receive or pay discount. So if it's monthly, M is 12. If it's quarterly, M is 4. T will be the number of years. And D raised to the superscript parentheses M is the nominal discount rate compounded M times per year. And again, we'll never use that value alone in a computation. We'll always divide that nominal rate by M to get the monthly effective discount rate. So the monthly effective discount rate would be D superscript 12 divided by 12. And then here is the compound discount formula with some slight tweaks. Instead of just a D right here, I have my period effective, my monthly effective discount rate right here. And instead of the number of years as the power, I'm going to have the number of periods as the power. So this is monthly, I'm going to have a 12t up here because 12 times the number of years would tell me the number of months I'm going to be pushing this money through, all right, or dragging it back as the case may be, all right? But this is exactly that AVT 1 minus D to the T formula, but applied to a different span of time, okay? All right, so let's work an example with this. We're told that the nominal quarterly discount rate is 6%. We have a loan of $8,000 that has to be paid off with a single payment at the end of 27 months. Let's determine the amount of that single payment, right? Well, what have we been given? We've been given the initial value, the present value of the loan is $8,000. We've been given that discounts happening 4 times a year quarterly, so M is 4. And we've been told our nominal quarterly discount rate, D superscript 4, is 0.06. And remember that superscript is not a power because it's in parentheses, all right? So parentheses will always indicate not a power, it's just notation, okay? All right, well, I don't need nominal discount compounded quarterly, I need effective discount compounded quarterly. So I'm gonna take that nominal rate and divide it by 4. So 6% divided by 4 is 0.015. In other words, 1.5%. All right, and there's my time value diagram of money. Okay, now I need to look 27 months in the future. That is 2 years and 3 months. And 3 months is 0.25 of a year, 3 out of 12 months. So 27 months is 2.25 years. So the T value I'm looking at is 2.25. And my goal is to figure out the accumulated value at time 2.25, because that's what I have to pay back, right? Well, down here is the formula from up above. Present value is equal to the accumulated value at time 2.25, 1 minus the quarterly discount rate, raised to the number of years times 4. So 2.25 years and 4 quarters in a year. Right? Sliding over one, present value is 8,000. The accumulated value is what I don't know, but I would like to. Quarterly effective discount rate is 0.015. And 2.25 times 4 is 9. So I'm pushing this money 9 quarters into the future with a quarterly effective discount rate of 1.5%. All right, well, I can divide the 1 minus 0.015 to the 9th underneath the 8,000, and I crank out that the accumulated value is $9,165.66.